So welcome to the next lecture class on centroid uh, of engineering mechanics subject. So welcome to the next lecture class. And today's learning objectives means what you are going to learn today. Nothing but learning objectives. Let us see what you are going to learn today. So by the end of this class, you'll be able to locate the centroid of certain rectangular shapes such as a rectangle, triangle, regular shapes such as rectangle, triangle, rhombus, trapezium, circle, and semicircle, etc. So how to locate it? Okay, of a rectangle, not by the formula, just how to locate it using some simple methods. Okay, so for all the only for centroid. Next, understand how to apply the analytical method to calculate the centroid. Next, let us see analytical method. Analytical method is nothing but what we have discussed in the last class. That is nothing but so these formulas. X bar is equal to sum of all the moment of areas divided by area of them. And similarly, y bar is equal to moment of area about the y-axis divided by area. Okay, this is nothing but moment of area about x-axis divided by area. That is nothing but x bar. And y bar is equal to sum of the moment of areas of all the figures about y-axis. Is nothing but into x-axis. Into x-axis, and this is into about y-axis. Okay, this is moment of areas about the y-axis, and these are moment of areas about the x-axis. It is y x is there means about y-axis. If it is y is there means about x-axis. Okay, so it is the point inside. Of course, centroid we have defined it. So what is centroid? Centroid is nothing. It's a point inside our where it's nothing but simply we can say that where total area is assumed to be concentrated. Okay, total area is assumed to be concentrated. It may be that location may be inside or outside. Depends on geometrical shapes. Some shapes, most of the shapes will have the centroid will be within the body only. But whereas some areas, some sections are there. So for them, especially the centroid lies outside the section. Okay, outside the area. Okay, for example, angle section, channel sections. For these sections, most of the cases that will lies above outside the section. Now let us see in this chapter how to calculate and how to do it. Right now, let us see the regular centroid for the regular areas. Regular area means like a rectangle, square, etc. If an area has axisymmetry, centroid lies on the axisymmetry. That's what we have learned. Okay, if a centroid, if a area is having any symmetric about any of the axis, obviously centroid lies on that axis. Okay, right. The centroid lies on the axis of symmetry. We use this principle to locate the centroid. A rectangle and square areas in the shape of rectangle or a square have two axes of symmetry and their intersection locates the centroid. So rectangle and square, so areas in the shape of a rectangular square have two axes of symmetry, right? So that's what we have also discussed in the last class also. So rectangle and square, they are having two axes of symmetries like x axis and y axis. Central x and if it is x passing through the center, and along the y-axis also passing through the center. That both will, this x-axis will divide into two horizontal parts and y-axis divides into two parts. Okay, so both divides these areas into two parts, equal two parts, having same area. So that's why they are called axis of symmetry about two axes. In that case, the centroid for this when any section or any area is symmetric about two axes, then centroid lies on the intersection of symmetrical line of symmetry. Okay, on the line intersection point on the line of symmetry. So that is not the intersection locates the centroid. Okay. So if you take the rectangle and square, so this is a rectangle, right? So if you join two diagonals, okay, diagonal points, so their intersection, okay, is nothing but centroid. This is one method. Other method is nothing but if you draw two line of symmetries, okay, symmetric lines. So this is one symmetry, line of symmetry. So other one is another line of symmetry, this one. Okay, so this is nothing but your intersection point. So this intersection point indicates the centroid of the rectangle. Okay, so either you draw these two, or if you draw two symmetric axis, symmetric line of axis about x, symmetric about x-axis, symmetry about y-axis. If you draw it both, then they will intersect at one point. That is nothing but centroid and rectangle. Right. Next one is square. Okay, square is nothing but this is a square, and if you join these two diagonal points again, just like your rectangle, so they will intersect at one point, right? So that is nothing but your centroid for the square. Or if you want, the other method is to draw the line of symmetries. They will intersect again at the same point, right? They will, if you do like this, or if you both, if you do it, that they will intersect into only one point, that is nothing but your centroid for the square and rectangle, right? So these are the symmetrical about both xx, this is xx axis, and this is yy axis. Okay, similarly this also xx and yy axis. Like this you can locate the centroid for the simple rectangle and squares. Now let us see the parallelogram and rhombus. There are two axes of symmetry and their intersection locate the centroid, right? So in this case it is draw the line of symmetries, axis of symmetries. Okay, this is y axis, this is x axis. Okay, so parallel, this axis shall be parallel, not vertical. Okay, this axis shall be parallel to this one. Draw a parallel at the center that will divide the two into two parts. Similarly, this is x axis divides this area into two parts. Okay, that intersection point is nothing but your centroid. The intersection point, this one is nothing but your centroid. Centroid. Similarly, either you can join this like this and like this, means to join the two diagonals. Okay, so like that also you can look at the your what is called centroid of the rhombus. Okay, centroid for the rhombus. Next, triangle. Now little bit, it is little bit of different. It is there is, because triangle is not symmetrical about any of the axis. See, in that case line of symmetry principle does not work, so we have to see the other method. Okay, so if we join any vertex of a triangle to the middle point of the opposite side, such as a line known as a median. Okay, so in this case we cannot use the axis symmetry principle, neither it will have any four sides to draw diagonals. Okay, so in this one you can use other method, that is in the drawing the medians. Okay, so drawing the median means joining between any vertex to the midpoint of the other side, opposite side. Okay, so that we call it as a median. So if you draw a line drawing the medians, draw the all the medians. Okay, they will all three intersect at it is only one point. That point is nothing but again it is we called as a centroid. Okay, if you divide the triangle into a series of thin strips parallel to the sides, then it is easily seen that the centroid of each strip lies on the median. So if you see, let us see that. Therefore, if you draw two such medians, their intersection locates the centroid of the triangle. Right? This is a triangle. This is a first median. This is a vertex point and median. This is nothing but center point of this line, opposite side. Okay. This is the first vertex point, the center point of the. Similarly, draw another one. Okay. So that is nothing. Its intersection point is the center. If you want again one more clarification, you can draw another one also. Two is sufficient, but you can draw the three also. Third one also, no issue at all. So all three will intersect only at one point. Okay. If you draw two or three, they will intersect only at one point. So that is nothing but your centroid. These are nothing but medians. This is nothing but centroid. So your total height is your height of the triangle is h, and it will, this point lies at a height of h by 3. Okay. Okay, you draw it, and if you take a triangle, okay, simple any triangle, it may be equilateral or unequilateral, equilateral or any other triangle. Draw triangle and draw the medians and see that, so they will meet at one point. That point, if you measure it, and to the height, you measure the height and you measure this point, intersection point, it shall be 1/3 of this height of the total triangle. Okay. That's what you are. Even if you draw number of lines like this, okay, that will also will intersect this point also. This will pass through that point. Next comes a trapezium. Okay, trapezoidal shape. So how to find the trapezoidal? If you join the middle points of the parallel sides, then the centroid lies on the midpoint of this line, as all element strips parallel to the parallel sides have their centroids on the line. Okay. So this is a trapezium. So right one. This obviously this is a symmetry, axis of symmetry. Okay. So if that will generally it will lies on this one. Right. So if it lies on this one, centroid lies on this line. Okay. So that will be, if you draw all these lines, so it is nothing but centroid lies on the midpoint of this line, as all symmetric elemental strips are parallel to the parallel sides have their centroids on this line. Because if you see this one, it will be a length of, let us say, 1 meter. Generally it is nothing but just like it is a line. Line is that the line center lies on the at the midpoint. Similarly, if you line draw here, midpoint. If you line draw here, midpoint. If you line, if you connect all these things, this is the nothing but your line. It is nothing but line of symmetry or axis of symmetry. Okay. And if you derive the formula, so derive means if you apply the formula analytical method, then you will find this y bar is equal to h by 3 plus 2a plus b by a plus b. This is very, very useful formula in the case of sometimes uh, what is called a dams and retaining walls case. This is a formula is required. Okay, otherwise we can calculate the at any point by applying the first principle, but is every time applying the first principle it is nothing but a little bit of time taking and so time waste. Okay, so instead of that one, you can remember this formula to get the centroid of this figure of an area. Again, to find the centroid of using first principles, again this you have to divide. This is not a regular figure, so you have to is a combination thing, but you have to divide this into one rectangle and two triangles. Right, one rectangle and two triangles. So if you divide this into area and divide number it 1, 2, 3 and calculate the moment of areas and calculate the areas and find the centroid of this figure. Okay, so how to find the centroid? Again, centroid or x bar or y bar is, of course in this case we need the y bar, because the x bar is already it will lies on this one at the center only it lies. Okay, there is no need to calculate the x bar for this case, only need to calculate the y bar. So y bar is equal to what? Sum of the right, sum of the dA y, algebraic sum of dA y divided by a, nothing but sum of the algebraic sum of the moment of areas about x-axis divided by area of the figure. Okay, so the area again you need to divide into calculation of area is easy, no problem. But if you find the area and calculate the moment of areas of two triangles and one rectangle and add it, divide by total area, that will give us the y bar. Okay, so this is how you have to calculate the trapezium, of course. Next one is circle. Symmetric is circle is symmetrical about all its diametrical axis. Diameter, all the axis along the diameters. Okay, all its diameters. Okay, the intersection of any two diameters, that is the center of the circle, is centroid. Okay, so just draw the two line of symmetries, any two. Okay, so it is, if you take this circle, it is symmetrical about this axis, this axis, this axis. It can be any number of any axis. If you take along its diameter, it's nothing but that will divide the area into say two parts. Okay, symmetry. So if you draw any two symmetries, so generally that intersection point is nothing but your centroid. So this is nothing but centroid. So that will, where it is means it will be nothing but center point. Okay, either if you take the radius r, then it is nothing but a distance of r. If you take consider the diameter, then is it d by 2. Okay. That's where the centroid of the circle lies. This is center point. Centroid of circle is the center point, center of your circle. Center of circle is the centroid of the circle. Both are one and same. Points are same. Next, semicircle. A semicircle is symmetrical about only vertical axis. Okay, so the line of symmetry, this is nothing but symmetrical. This is symmetrical about y-axis. Obviously, this will lies your what is called our line of symmetric centroid lies on this axis of symmetry only. Okay, so it is nothing but from here to here it will be half, because it will, this symmetry means this will divide into two halves, equal halves. Okay, so that's why it is 2 are equal. That's why it will be half of the distance. Means it is total diameter, then is d by 2 this time. Okay, that's nothing but if you want to x bar from this line, it is nothing but d by 2. Okay, that's no issue at all. No calculation is required. Directly you can see. But if you want this y bar, then that y bar is nothing but it is 4r by 3 pi from the base diameter along the line OA. Okay, this is a line along the OA. So on this line, OA is nothing but it's a symmetrical y-axis. Okay. So this is okay. This is the radius r. This is nothing but 4r by 3 pi. So some of the generally used geometric shapes and their centroids are given, right? So it is, let us say this is a rectangle, sorry, square. Okay, for square that will be area will be L square. Of course, last class also we have discussed about it. So it will be L into L is nothing but area is nothing but L square, and it is center means if you join these 2 points, it will be at the center. So midpoint is nothing but this point is the midpoint from here to here. That is nothing but L by 2. Similarly, for this also it is square base. That's why both sides it is L by 2 only. Right? If you take a rectangle, then okay, this is L into H and L by 2. This is half distance is L by 2, and this is y bar is equal to H by 2. Okay. So L by 2 and H by 2. Half into base in triangle, the area is half into base into height. So half into base is nothing but L and height is nothing but H. So half into base into height, and X bar is equal to X bar is nothing but X bar is equal to this lies on this vertical about the on this line it is lying. So it is nothing but where it lies means at a distance of L plus A by not a 1. This is L plus A by 3. So this is L, this is A, and by 3. Okay. So if it is a both sides it is equal, then it will be generally it will be L by 2. This formula reduces to just L by 2. Okay. Right. Whereas the height is nothing but this will be H by 3. Okay. Whatever the type of triangle, that the height will be H by 3. Either it is a right angle triangle or any other triangle, that y bar will be always H by 3 only. H by 3 from the base. Okay. So base of the triangle, that H y bar is. Right, next for the trapezium. So for the trapezium, for the trapezium, area is nothing but h by 2. H by 2 into a plus b means a plus b, average width into height. That is nothing but average width is nothing but a plus b by 2, and it is height is h. That is nothing but your area. So a plus b by 2. So a plus b by 2 is nothing but a is nothing but top width and b is nothing but bottom width. A plus b by 2. Right. Next 2a plus b by a plus b. 2a plus b by a plus b into h by 3. Next, parallelogram. So parallelogram formula is it is if the side is b and width is base width is b, and it is your inclined height is your what is the inclined, it is this one dimension. So, a, I think a. Okay, so if this is a and this is b, then it is ab sine theta. So is the area, and your x bar is nothing but b plus a by cos b plus a cos theta by 2, and y bar is equal to a sin theta by 2. Parallelogram. Better to remember. Of course, this may not be as per syllabus. They may not. Better to remember all these things. So circular, already it is very simple. It is a diameter r. The diameter in terms of diameter, it will be d by 2. It is in terms of radius, it is r. Area is pi r square or pi by 4 d square. So quarter circle area. Quarter circle area. So it is mean 1/4 of the quarter circle. Area will be 1/4 of the area of circle, and it is you already we discussed that this is a x bar and y bar. In this case, both cases it will be 4r by 3 pi only. Okay, how much is 4r by 3 pi? Next, semicircular area. So this is means half of the circle. That's why half of the area, and x bar is nothing but from here to here. Okay? So it is nothing but from here to here. Okay, so this is a reference axis, and for y bar this is a reference axis. So here to here is nothing but y bar, and here to here is nothing but x bar. right? So x bar and y bar. So and what is the y bar? Y bar is equal to 4r by 3 pi. Y bar is equal to 4r by 3 pi. Next, arc of a circle. So this is only arc of a circle, not the sector. This is sector. This is a means sector is nothing but it's a part of circle. Okay. So whereas the arc of circle is only line. Okay. So this is just a line and its center is this one. Okay. This is nothing but arc of a circle. Okay. And the radius is r. Okay. This is from here to here. It is no area. Doesn't have any areas. This is just lines, radial lines. Okay. So whereas this is a part of your circle. This is the entire thing is a part of circle. This is also area. Okay. So in this one, if you see, so our area is nothing but 2 alpha r. Alpha is nothing but if it is line which divides this area into angles. So it is nothing but alpha. Right? It's nothing but total included angle by 2. Alpha is nothing but r is nothing but radius. And next one is x bar is equal to r sin alpha by alpha, and y bar is equal to 0 because this is x axis. Okay, centroidal x axis. It is because this is symmetric. This x axis divides this area into two parts. So it means obviously where the centroid lies? Centroid lies on the line of symmetry. So this is line of symmetry. So in this lines it lies. Okay, on this line only it is lies. That's why it is y bar becoming 0. And similarly, circular sector. Circular sector is the area is alpha r square, right? So and x bar is nothing but 2 what is that alpha, not alpha, it is a 2 r sin alpha by 3 alpha. Okay, this is nothing but your x bar, and again y bar 0 because this is a line of symmetry. Your centroid lies on the line of symmetry. That's why it is x bar equal to 0. This both cases, sorry, y bar is equal to 0. Similarly, ellipse is pi AB, and it is again x bar. This is a reference axis. So from the reference axis, it will be at a distance of a. And semi-ellipse, so it is pi AB by 2. So AB full ellipse means pi AB, and half of the ellipse means pi AB by 2. Okay. And a okay, pi AB by 2 a, right? And the area is this not 4b by 3 pi. 4b by 3 pi. And parabola, so this is a parabola, and this shape, it is parabolic shape. It is area is 4ah by 3, and it is distance is from this one. It is obviously it is symmetric about this axis, so that's why it is from this point it is a, and it is 2h by 3 because this height is, will if you calculate you will get as 2h by 3. Right. So this is parabolic, half parabola. Of course, this is very much required. Okay. So in the case of shear force bending one diagrams, while you are drawing, it will be half, and as well as in case of deflections, these areas are very much required. In case of calculation of deflections, and so many other engineering problems, you need to know, you need to calculate the areas of these parabolic shapes. So in that cases, these formulas are very much important, and as well as this centroidal distance, very important, requires. Okay, even this ellipse and parabola, this parabola may not be required, but these two will be very useful and requires. Okay. So for this one, if this shape is like this, so it is nothing but just like it is like a rectangle. Okay, just assume that is a rectangle. Okay, so with a as base as a, height is h. Okay, this dimension is h. So what is the rectangular area? Rectangular area is a into h, right? So this is the area of the rectangle. That is one thing, and it is where the area means what is the, but there's a rectangle area, but this is not a rectangle. This is a parabolic. It will cut into this. It will shape in the shape of this one. So when this is the shape is nothing but this one, for this one, so it will be area will be comes around 2/3 of ah, means 2/3 of rectangular area, whereas this one will be 1/3 of rectangle. So that if you add these two, you will get ah means rectangle. These two will forms a rectangle. Okay, so this is 2/3 of rectangle area. This is 1/3 of rectangle. No formula, nothing is. If this shape is like this is 1/3 rectangular area. If the shape is like this is 2/3 rectangular area. right? And next one is its parabolic shape for this one. So your x bar is from here means reference axis here. So from here to here it is x bar, right? So y bar means from here to here it is y bar, right? This is 3 by 5 a, and this is 3 by 8 h, and whereas this one, and it is this one, for this case, this where x bar is nothing but your 3 by 4a means from here to here 3/4 of the distance, and from here to here what 1/4. Okay, from here to here it is 3/4, and height is 3 by 8 h, 3 by 10 h. With all the cases, it's observe it. 3 will numerator will be there, 3 will be there in the numerator. Always 3 will be there in the numerator. Okay, so that's what you have to remember. Okay, formula remembering in case you have to, all 3 will be there always for the any x bar or y bar of these two parabolic shapes. Now let us see one sample calculation. So in the case of triangle, how to calculate the x bar and y bar. In the case of triangle, we have already observed that. So we have seen in this diagram that in the case of locate the centroids, we have seen that x bar y bar is equal to, so it is h by 3. Okay, now let us see whether how to calculate this h by 3. So from the method of moments, location of centroid is given by x bar and y bar. X bar is nothing but so moment of areas about the x-axis by y-axis. Okay, about y-axis nothing but dA into x divided by a, and this is nothing but moment of areas about. What is this? Both are explained. Okay, so only one formula is there, and similarly dA by moment of areas about the all the areas about the all elemental areas about x-axis is nothing but y divided by area, sum of the area. Okay, sum of the all the areas is nothing but areas. That's why these are different formulas. Next, the summation can be done by integration and is the most fundamental method of locating the centroid and CG and centroid. Okay. Summation from the, this is called the first principle. From the first principle, you have to find out. Okay, so dividing into taking into elemental step one step, and it is integrated or summation. Okay, summation can sum all the areas as x bars of all the elemental steps. That's nothing but integrate. Apply the integration. So I do the integration and find the x bar and y bar. Now let us see for triangle to calculate the centroid. Okay, these are the reference axis. Okay, this is the x y axis and this is x axis. Okay, yeah. Now see. So these are the x and y axis, and these are triangle having a height h and base equal to b. Right? Height h and base b. And take a small elemental area. Okay, elemental strip. So that is the thickness of the strip is nothing but dy, because we are taking the this direction. It is very very small, infinitesimal small means very very small area. That's why we are taking the term dy. Okay, so dy, the small thickness of this strip is nothing but dy, and it is the width at this point is nothing but your x. Okay, so the width of this axis is this point is nothing but x, right? So now if what is the area of the strip means, so we need the area of the strip. Okay, area of the strip is equal to what? A small area is nothing but dy into x into dy. Okay, that is the area of this strip. Okay, now if this is one strip, one area like this, there are number of strips are there from the 0 to h height. Okay, from the 0 to h height, there are many strips are there, right? Now you apply integration, apply the integration principle or sum the all the term. Okay, this is one strip, one strip. What is the this moment of a moment area is nothing but x into dy, that is the area. What is the first principle? X resultant of your resultant moment of area is equal to the summation of all the moment, that is the sum of all the moment of area of these small infinitesimal areas. That is nothing but you have to use that principle. That is nothing but x bar into a means resultant. X is like a area is nothing but total area is nothing but resultant. Okay, if you assume A into X bar is nothing but where the total area assumes to be act. Okay, that is nothing but X bar is equal to small areas. There are many areas are there. The summation of all these moment areas is nothing but your moment area into moment. Okay, that is nothing but you have to calculate and sum it of all these small areas. How to do? So first it is nothing. What is the first? What is the area we have considered? Small area, that is nothing but x into dy. That is the area. And what is the moment? How to calculate the moment of area? So far we got the area. We have to calculate the moment of area. Moment of area is area into distance from the reference axis. So what is the distance from the reference axis? That is nothing but y. Okay. Now it is nothing but what is the formula of integration becomes x into dy into y. Okay, x dy into y. So that is the your moment of area of one point. Similarly, if you want all the things, then integrate it. Select x and y axis as shown in the figure. Right. So select the x and y axis as shown in the figure. So that's what we have seen. And consider an element area of width, say x, and height dy at a distance of y from the base. Okay. So consider an area, small thickness of your area, that is nothing but dy, and the height from the x-axis is nothing but y. Now, what is the area of the elementary strip? The elementary strip means just like it is a rectangle because very small, even though the small variation is there at the ends, but it is very small because of very small, it is just like you assume it as a rectangle, right? So that what is the area of rectangle? Width into depth, width into thickness. That is nothing but width is nothing but x and your thickness is nothing but dy. That's why it is x into dy. And moment of area about x-axis. Moment of area is area into centroidal distance. It's centroidal distance. That is nothing but centroidal distance or its distance from the x-axis, because when the area itself is a very small, dy is nothing but very small area. Again, centroid or center, the distance from the y-axis will be very the same. Okay, it will be equal. You can say equal. It is not exactly equal. We can say that it is equal because the thickness is very negligible. Okay. So moment of area about the x-axis is equal to x into dy into the distance is nothing but y. Okay. Now we got the moment of area for the one step. Right. So if you want all of them, you integrate it. So the integration will be done with reference to y within the limits of 0 to h. Okay. So integration have to be done with respect to y, from the limits 0 to h. 0 to h is nothing but your triangle will be from the started. It will be lying on the where x-axis means that is the x is equal to y is equal to 0, and to the height is nothing towards the y-axis. That's why it is what is the height of your triangle h. That's why limits are nothing but your 0 to h. Okay. And it is therefore necessary to express x in terms of y. X also you are in terms of y. This can be done by from the single triangle with base h, x, and b respectively, and we get. Okay. So that is nothing but what is our formula? It is nothing but we are moment of area is nothing but x into dy into y, x into y into dy. Okay. So x y dy. But to integrate this entire equation, the x also shall be in terms of y. Okay. X is not a constant. X is also variable. Okay. So from it is the shape of a triangle also variable. From one place it is maximum, one place at the vertex it will be 0. At the base it is maximum, at the vertex it will be 0. That's why you have to convert this x also into y. Okay, in terms of y. Then you integrate it. Okay, so that it will be variable also. It will be included because this is variable in both directions, x direction as well as y direction. That's why convert any one into other so that you can integrate it with respect to any one reference axis. That's what we are converting. Otherwise, no conversion requires. Yeah. So now it is nothing but using similar triangle principle. So you calculate this one. Okay. So how to apply a similar triangle principle? Just I will take a small picture of it. Okay. So this is let us say this is one thing we are considered. This is your x. That's what we are assumed. Right. So this width is x, and this bottom width already we know that triangle bottom width is b. and height h is nothing but your height is h. Okay, height is h. Right. So using this triangle, now we calculate we express this x also in terms of b, y, and of course this distance is y. So this distance is y means this distance becomes h minus y. Now, if we take the triangles, let us say it is triangle OAB, and let us say it is CD, right? So there are two triangles. One is triangle OAB, and similar other another triangle. Sorry, it is better to write it is AOB, not AC, because angle at this point is same. Another triangle COD. Okay, angle AOB, triangle AOB, triangle COD. At this point, for the say at the O, both will have the equal angles. That is one thing. That is this one. Another is this one. So this is nothing but now use a similar triangle principle. Okay. So because the angle is same, the distance means this distance accordingly this varies means this also varies, right? If this height varies, this width also varies. That's what your similar triangle principles. The ratio is constant. Okay, distance of your base from the height, the ratio will be constant. Okay? Distance of your distance from the this vertex point and to this opposite side, the ratio will be always constant. That is nothing but your similar triangle principle. Okay, so from that similar triangle principle, now you calculate x by b. We need x together, so I can just write by x by b. Means this by this is equal to, right? So this by this is equal to, or in other way you can say that. So we are writing that this distance, this and this will be the ratio will be constant together. So it is nothing but x by base divided by its distance from the your this point, x by its distance from the O is equal to, and b side opposite side b divided by its distance from the O, that is nothing but h. Okay, this is nothing similar triangle principle. From this you write x is equal to b by h will be same, and this is nothing but h minus y. Okay, that's what it is. X is equal to b by h minus b by h into h minus y. That's what the principle. X is equal to b by h into h minus y. Right. So now applying using now can substitute this x value there. Okay, in that previous x equation, moment of area, that is nothing x into dy into y. In that one, substitute this x value. Now let us see what happens. So moment of shaded strip about y z axis is equal to, so b by h into, not z axis, it is x axis. Okay, not z axis. So is equal to b by h into x minus y into y dy. So this is x. This is nothing but x into dy is the area. Y is the its distance from the x axis, right? So it is one more thing. It is not z axis. It is the x axis. Okay, strip about x axis is equal to this one. Right? So area of the triangle we know that half into base into height. So that is nothing but this one. If y bar is the distance of centroid from its base, then so it is nothing but x bar a moment of area. It's the area of the triangle into its centroid. Means it's like a force, resultant force, and it is like a its point of application. So that point of application we don't know. So that's what we have to calculate. So that we are assuming that is a y bar, and resultant force. The resultant force is nothing but already we know that it is nothing but a area. So moment of area. That's what we are saying. That's what moment is the area and this is distance. Moment of area. Right. Now it's a distance. Now it equal to now sum of all the result all the forces about the moment of area about all the forces about one point or moment of areas of all with respect to x-axis. Okay, that's nothing but this one x into y x into dy is the area and moment is nothing but into y, that is nothing but moment of area. Now substitute x in terms of here x by b by h into h minus y. In this case b by h is a constant, you keep it outside and h now integrate h minus y into y. Of course we get in y into also in terms of inside, so hy minus y square into dy, right? Now it is nothing but just like this one, right? So cross multiply, it will comes to denominator means comes to numerator. That's why it is 2 by bh into b by h constant term, to bring it to outside after integration. Now it is h minus y2. Now it is again directly written. Okay, so I will say it is in this case what b get cancelled and 2 by h square remains. That's right, it's 2 by h square. And what happens here, let us, I will one step is directly eliminated here, so I will explain here. So if it is bring this into the inside, that will become equation becomes hy minus y square into dy. So integral, okay, integral 0 to h, right? So 0 to h hy minus y square into dy. Now integrate it. So integration of h is again constant, only y is a variable because we are integrating with respect to y, means y is the only variable. So h into y square by 2, h into y square by 2, right? That's all. Next minus y cube by 3, y cube by 3 limits to the 0 to h. H means only apply wherever y is there, you substitute h. Of course, if you substitute 0, that will become 0, that will become 0. No, so that's why only upper limit only you will get the value. So 2 by b square into h square by 2 minus h cube by 3. That's what it is nothing but 2 into h cube minus 2 h cube minus 3. Take the LCM and simplify it. They will get y bar is equal to h by 3. So that is nothing but centroid of a triangle is therefore at a distance of h by 3 from the base. That's what we have discussed also. In the previous, we have seen our drawing the medians and is located in that what is called intersection point. From that also you can we have written, we have seen the same h by 3. Now it is proved. Okay, so like that you have to, from the first principle you have to calculate the centroidal distance. So like this, you take a small elemental step and calculate the moment of area and use the formula and calculate the centroidal distance from the first principle. This is for any figure, irregular figure, regular figure, from any figure. Just you by this first principle you can able to calculate the moment of area, centroidal distance for any figure, any shape, the rectangle, square, triangle, this and that, this, so many things. Okay, anything you can apply. But the only thing is that if it is whatever the curve it is or line is there, you should know the equation of that line. Okay, if you know that one, so that we can express into x into y, y into x, x in terms of y in terms of x, so that we can integrate it. That's what we the minimum requirement. That's all. Otherwise, remaining any problem you can do it. Now let us see steps. What are the different steps involving calculation of centroids? But normal problem in numerical problems. Following procedure is conveniently adapted locating. Choose the origin and coordinates axis so as to measure the centroid distance x and y, and determine by inspection whether the area has any axial symmetry. Means first you check whether the axial symmetry is there about any axis. If it is axial symmetry about any one of the axis, our problem will be half of the problem will be done, because about any axis it is symmetry means that centroid lies on that axis only. Okay, so that one half of the problem is eliminated. If axis symmetry is parallel to x-axis, then y bar is directly and y bar is known directly, and centroid is at midpoint, mid height. If axis symmetry is parallel to y-axis, then x-axis is known as directly and centroid is right on the width. That's what while discussing some of the regular figures x bar and y bar, I have explained to you how to locate it. Next, divide the area into simple areas of regular shape whose centroids are known. Means every, just like we have discussed, trapezium, trapezoidal shape. For the trapezium, so how to calculate means first you have to divide that rectangle, that trapezium into one rectangle and two triangles. That's all. Now you calculate the, go with the your three parts, 1, 2, 3, equal the number and calculate a1 y1, a2 x2, and similarly a2 y2, a2 x2 and a3 y3 and a3 x3, and calculate the area, total area, and calculate the x bar and y bar. That's what you have to do. Compute the areas of each small areas into which figure is divided. Locate the centroids of these small areas. In case of if it is any irregular figures are there, like if you want to calculate the first principle, then it is nothing but you have to divide a small area, that is nothing but elemental area. So calculate that area and assume the thickness and calculate the area and integrate it so that you will get it. Take the moments about origin O of the areas. This done by multiplying areas with the perpendicular distance from the origin of the line of action of these areas. The coordinates of the centroids x bar y bar can be obtained by using the formula. So it is x bar is equal to, so sum of the moment of areas about y axis divided by area, and sum of the moment of x axis divided by area equals the y bar. Where I explain the algebraic sum of moments about origin, considering the areas acting parallel to the y-axis, and the algebraic sum of moments about origin. So it is nothing but like this. Okay, so this is how you have to calculate the numerical problems. It is divided into number of parts. Either it can be a small strip and apply the integration, or if it is a regular figure, say if you want to regular figure, if you want to, you can able to divide it to regular shapes like the combination of rectangle, triangle, circles. Then you divide like this. You can calculate. That's how you have to do. So now let us conclude the today's one. So what we have discussed over, so we have divided the centroid of a regular areas, locating the centroids without measuring, without analytical problem, without analytical methods. So just geometrical by lines, drawing the diagonals, etc. for the regular areas. To calculate the location of centroid from the fundamental principles, we have done for this triangle. So similarly, we can do for the same thing. We can extend it to the rectangle. That is very simple. Compared to triangle, rectangle is very simple. Rectangle, circle, etc. Very simple. Steps in calculating the centroid of a plane geometrical shapes. So we have seen several number of formulas directly how to calculate it. Okay. So this is about today's class. So let us stop here. This is some small piece, of course.